Good day, Professor, and good day, ladies and gentlemen. Our group is Team 15, and for our final presentation, we talk about the water delivery system. For this report, we had 12 team members, and we selected Ranveer to be our team leaders. But for this presentation, we have 6 presenters, myself, including 5 co-presenters, namely Adele, Justin, Ranveer, the team leader, Samir, and Zokif. Thank you as you listen.
The objective of this project is to design a system to deliver potable water from a bore well to a residential apartment building in a rural area. The scope of this project includes developing a water distribution system for residential consumption, designing P&IDs and floor plan schematics for both the apartment building and the water delivery system from the bore well, and determining the sizing for any of the required piping or instrumentation required for the system. The proposed construction site is a rectangular plot of land with an area of half an acre that has road access on one side and land on the other 3 sides. The footprint of the 12 apartment complex is planned to be 60 feet by 120 feet. Any existing building structures on the plot have been slated for demolition, and the bore well used to supply the building is to be located close to the proposed site, somewhere within 40 to 300 feet. The given design parameters of the building are as follows. The building is a 12 apartment complex with 2 above grade floors and a basement. The first floor has 8 2-bedroom apartments with floor areas from 800 to 1,000 square feet. The second floor has 4 3-bedroom apartments with floor areas from 1,000 to 1,200 square feet. The ground floor consists mainly of a laundry room and other communal spaces like building entrances. Finally, the basement is partially below grade and serves as a storage area and mechanical room. For the design parameters of the water delivery system, it was stated that the bore well is 55 to 100 feet deep. It could support extraction rates of 3 to 20 gallons per minute. The water extracted needs to be delivered at a pressure of 100 psi absolute at the inlet of each of the floor risers. The water delivery system is limited to the design of water distribution for the purposes of residential consumption only, so our schematics will not include any designs related to wastewater or fire suppression systems. A schematic of the system related to the scope of the project deliverables was developed and will be touched upon later in the presentation. This schematic will include all necessary components of the system, including pumps, pipes, valves, any piping accessories, and anything else that may be required as laid out by the codes, standards, or our best judgment. For example, the minimum size of water main pipes should be 6 inches, and all drinking water systems should have flow measuring devices to measure the flow from each source and then convey that information to the water treatment plant.
With primary design parameters defined, other factors were considered. First, the water treatment for this distribution system has rudimentary filtration of the water only. This is due to the water source being assessed as potable. Flow measuring devices will be installed to measure the source water flow as well as individual apartment flows for characterizing the supply need and consumption behavior of residents. The storage tank will be housed in the basement for accessibility, serviceability, and to reduce any freezing hazard. Per the Ontario Building Code and Ministry Design Guide, a minimum pipe size for the main branch distribution of water is 6 inches in diameter. The distribution system, regardless of design, must be safe. Redundant pumps, pressure relief valves, and design for isolation and serviceability are incorporated into the building. Galvanized steel is the selected material for the bore well and water distribution system since it is readily available in standard sizes and corrosion resistant. Rate calculations. Statistics Canada data for the year of 2019 were used as no in situ study was possible. Safety standards, as well as recommended practices and parameters, were derived from the WHO and World Plumbing Council. Since the building is in rural Ontario, our design must comply with the Ontario Building Code and meet guidelines as found from the Ontario Ministry of the Environment. Per the guidelines set by the Ontario Ministry of the Environment, a provision for the storage of potable water must be included for residential buildings. The calculation for the size of the capacity explicitly states that the minimum calculated capacity of the storage tank should be the sum of 25% of the design year maximum day consumption and 40% of the design year average day consumption. That is, take 25% of the highest daily consumption expected from the building plus 40% of what the typical daily average consumption is of the building. This number is calculated to be 15,000 liters, which corresponds to 2 hours of consumption at the absolute maximum rate, with the well supplying the minimum 3 gallons per minute. To add extra safety to this design, the team selected a 25,000 liter tank instead. This gives headroom for residential consumption should the bore well have a long period of reduced production. This change was incorporated given that tanks of this size have been found to cost between only 5,200 and 7,500 Canadian dollars. These prices reflect a very small fraction of the overall construction cost, but tremendously add to the safety and reliability of the distribution system.
The following two slides show the PNIDs for the water delivery system. This image shows the PNID for the basement and is called process B. The process starts at the bore well, passes through a pump, and then moves through three valves before it enters the filter, after which it goes into the storage tank. The check valve prevents water from flowing back into the pump. The gate valve helps control the water flow and to choose whether it's on or off. And the globe valve helps changes Q, or the water flow rate. After the storage tank, it splits into two different lines. One line is a redundancy for if the main line fails. There's a pump and a check valve, another pump and another check valve. The two pumps are connected in series so that the overall head of the system increases. After this, it splits into three different lines. Each line goes to a different process and a different floor, after which everything collects into the septic tank. The image at the bottom shows process M. The process M is fed from process B, which is the basement, and the cold water inlet is fed into the system. After this, the line branches into two sections. The second section here, it has a heat exchanger which heats up the line. Therefore, there's a cold and hot water line to the rest of the floor. These lines get fed into 6 washing machines and 6 dryers, after which they go to the septic tank. The image on the left shows process F1, which is the PNID for floor number 1. The inlet branches into 8 different lines because there are 8 apartments on this floor. For a given apartment, the cold water inlet branches into the water heater so that there is both a cold and hot water supply to the rest of the apartment. These lines are then fed to 3 sinks, 2 water closets, and 2 showers, after which they are drained into the septic tank. This image shows the PNID for floor number 2, and it's called process F2. This floor has 4 apartments, and for each apartment, the lines go through the same process as shown in process F1.
Two pumps are needed to distribute the water from the storage tank to each floor riser. The sizing of the pumps is based on the following criteria: a maximum flow rate of 36 gallons per minute, a height of 30 feet, which is the distance between the basement floor and the second floor riser, a total head loss due to the various fittings and pipe material in the system. Using Bernoulli's equation, we obtained the pump head, and to accommodate the 70 meters, we used two similar pumps in series. From the TACO chart, we picked two suitable variable speed pumps with the same stats. Each pump has an efficiency of 46% and a maximum RPM of 3500 at 7.5 horsepower. The borewell extraction pump, which supplies water from the borewell to the storage tank, was sized depending on a maximum extraction rate of 20 gallons per minute, a borewell depth of 60 feet, and a total head loss that corresponds to the different types of fittings and pipe material we chose. By applying Bernoulli's equation, we determined that the pump head is around 80 meters, and picked a suitable variable speed pump from the TACO charts. The borewell extraction pump we picked has 26% efficiency and a maximum RPM of 3500 operating at 3 horsepower.
Schematics. This section will outline different floor plans and layouts. The image on the left shows the location of the storage tank relevant to the ground floor, and it also shows the arrangement of the parking lot. The image on the right shows the location of the bore well relative to the plot, and also shows the location of the septic tank. Basement floor plan. This is a floor plan of the basement, and the green line is the wastewater line, and the blue line is the cold water line. The left side of the plan has storage compartments or storage rooms for each apartment. And the floor plan on the right shows a mechanical room, which contains the pumps, valves, filters, and any other instrumentation. It also indicates the location and approximate size of the storage tank.
This is the floor plan for the ground floor of the building. It has one main entrance and will hold the lobby and offices for any maintenance or management staff. This floor holds a laundry room with multiple washers and dryers, and the details of which are going to be discussed in later slides. This floor plan shows the details of the first floor of the building. There are a total of 8 apartments on this floor. Each apartment is identical with 2 bedrooms, 1 living room, 1 kitchen, and 2 attached bathrooms. Each of the apartments are between 800 and 1,000 square feet as per the design requirements. The piping system for the water distribution is identical for each of the apartment, and the details are going to be discussed in the next slide. In this slide, we'll be discussing the piping diagram for the laundry room and the apartment. The laundry room is designed for 6 washers and 6 dryers. All 12 spots are provided with a water line to allow for flexibility in the equipment placement. Each bathroom consists of 1 sink, 1 toilet, and 1 bathtub. The kitchens of each apartment has 1 sink but no dishwasher. Each floor receives a water line through the service duct, which branches off to a water heater specific to each apartment. This water heater provides the hot water system for the apartment. The green line in this diagram depicts the wastewater system, and the red and blue lines depict the hot water and the cold water lines respectively. The floor plan for the second floor shows 4 identical 3-bedroom apartments and some terrace space. Each apartment is identical with 3 bedrooms, 1 living room, 1 kitchen, along with a den. Each apartment has 2 bathrooms, and the piping diagram for the bathroom and the kitchen are identical to the ones on the first floor. The picture on the left depicts a sample of what a typical bathroom would look like in this building, with the hot water line and the cold water line bringing water into the bathroom and the wastewater line taking the water out. The lines are depicted on the picture on the right with green for wastewater, red for hot water, and blue for cold water lines.
Thank you all for listening. And if you have any question, feel free to ask. Thank you.